Hello, in this video, we will show that the coefficient of expansion is the same as the coefficient of regression. And the coefficient of regression can be generated using linest. So we begin with the expansion of the exponential function. So we have RA formula, exponent of the x values. We show the chart for this in the exponential form. We show the equation as well. You will notice the equation is 1 times e to the power x because it is the equation here is 1 exponent 1 8 exponent x. So but we're interested in the expansion, the Maclaurin series expansion of the expand of this function. So we will generate the Maclaurin series, which is equal to the summation of x to the power n over n factorial. N factorial is the coefficient of the expansion. And the values of n will start from 0 to infinity. In this case, we're limited to our data set range. So that's 0 to 6. And we calculate the coefficients, which is our formula of 1 over factorial, the n values. So we have the coefficients of the expansion. We generate the expansion, the Maclaurin series expansion, which is our formula, series sum of the x values raised to the power 0 because x to the n is 0, that's the starting, incremented by 1 because the next value is 1, so incremented by 1, and the coefficients will be this series sum. Our expansion is a good approximation of the function. We can make this more accurate if we add more data sets. But for now, we can compare this in the chart. So we add the series to the chart and we show the equation as well. See if they match. You will notice there's just a small difference of the equation. Our equation here is 1 times e to the x. Here is 1.32 times e to the minus 1x. But we're more interested in the polynomial regression. So we use the polynomial raised to the power 6 because there are 6 data sets here. And we show the R squared. So this shows the coefficient of our expansion. 1 is 1 here, zero point 0.5 for A2, A0, A1, A2. So A0 and A1 are the same. A2 is zero point 0.5, A3 is 0.16, A4 is 0.0417, and A3 is 8.33 times 10 to the minus 3, and A6 is 1.39 times 10 to the minus 3. We will calculate these coefficients using linest. So to do that, we will first generate the we'll generate the 1 comma x matrix for this. So for the first, this will be transpose of the x values. So we have the power, and then we generate the 1 comma x matrix, which is RA formula of the x values to the power 1 or to the power 0. So we have the 1 column, and then we lock the references. And drag this so we have the x squared column. This is the x column, which matches to this x value. Then the x squared column, and the x cubed column, and then the x to the fourth column, and then the x to the fifth column, and x to the sixth column. Now that we have the 1 comma x matrix, we can use the linest. Linest of data y, because we are interested in comparing our coefficient of expansion of the with the coefficient of regression. So data y, comma, and data x. So our coefficient of regression matches to our coefficient of expansion. And we'll show the full statistics of this linest. So you will notice the f statistic is infinity, so it cannot be shown here. But our degree of freedom is zero. That's because that's why we have the same value of the coefficient of regression to match with the coefficient of expansion. This completes the comparison of the two coefficients of the expansion and the